Hello everyone. In the previous session, we had discussed about memory management. In this session, we will be discussing about scheduling algorithm and what are the various scheduling algorithms available in operating system. Now let us see the definition of process scheduling. Process scheduling is an activity performed by the process manager in which running process is removed from the CPU and it is given to some other process based on certain strategies. Process scheduling is one of the most important aspects of multiple operating systems. In this case, operating system will take more than one process at a time and it is kept in the executable memory, and the same CPU is being shared among all the processes based on time multiplexing. Now let us discuss about another concept, which is process scheduling queues. The operating system maintains all the process control blocks in process scheduling queues. The operating system maintains all the process control blocks in such a way that each of the processes which are in a certain process execution state will be in the same queue. So in this case, the set of process control blocks containing all the processes in the same state will be present in the same queue. So as a result, whenever one process changes its state from one to another, then in such cases that particular process control block will be changed, that is, it will be unlinked from the current queue and it will be given to the new state queue. Now let us see what are the types of process control queues available. The first type of process control queue available is job queue. In this case, all the processes present in the system are kept in the job queue. The second type of queue available is ready queue. In this case, whenever a process is present in the main memory and it is ready to be executed, then it is given to the ready queue. In such a case, all the new processes are always present in the ready queue. The third one is the device queue or IO queue. In such cases, whenever a process is waiting for a IO device to occur or IO process to be occurred, in such cases all such processes are present in the IO or device queue. Now let us see about schedulers in an operating system. Schedulers in an operating system are special softwares in the system which are responsible for handling various software scheduling or process scheduling. In this case, the schedulers are the one which will decide which job has to be scheduled into the system and which process has to be run. In this case, the schedulers are mainly divided into three types. The first one is long-term scheduler, the second one is short-term scheduler, and the third one is medium-term scheduler. Now let us discuss about various types of schedulers. The first type of scheduler is long-term scheduler. It can also be called as a job scheduler. The long-term scheduler is responsible for deciding which program has to be admitted to the system for processing. It is the one which is responsible for taking all the selected processes from the queue and then putting it in the executable memory. The long-term scheduler is the one which will be performing all the loading of the processes into the executable memory and it will be waiting for the CPU scheduling. Now next, let us discuss about short-term scheduler. The short-term scheduler can also be called as a CPU scheduler. It is the one which is having the objective of deciding and increasing the performance of a system with accordance to the set of criteria given. The short-term scheduler is the one which changes the state of a process from ready state to the running state. Within a given set of processes, it will be deciding which process has to be taken and given to the CPU for execution. As a result, the short-term scheduler can also be called as a dispatcher. It is because it is the one which decides which process has to be executed next. The short-term scheduler is much more faster as compared to the long-term scheduler. Now let us discuss about next type of scheduler, which is medium-term scheduler. Medium-term scheduler is part of swapping. It is responsible for removing the process from the memory. As a result, it is the one which decreases the degree of multiprogramming. In case of medium-term scheduler, it is responsible for handling all the processes which are swapped out. Next is context switching. Before context switching, let us discuss about swapping. What exactly swapping is? Swapping is the mechanism in which one process which is running in the CPU is removed from the running state and it is given to the ready state, and correspondingly another process which is present in the ready state is removed and it is given to the CPU for execution. In this state, what happens is the context switching is the mechanism which stores and restores all the context or state of the CPU in the process control block. This is performed in order that whenever this process is resumed the execution, at that time whatever state it was lastly present, correspondingly the process will be resuming from that particular last point. This is how the context switching works. Context switching is one of the thing why lots of processes can access and share the same CPU. This is responsible for that. Similarly, multitasking operating system has lots of benefits as far as context switching is concerned. Now that we have seen various concepts as far as process scheduling is concerned, let us discuss about various process scheduling algorithms. Process scheduler is the one which correspondingly gives various processes to the CPU for execution. This is performed based on various scheduling algorithms. Now let us see some of the types of process scheduling algorithms. Process scheduling algorithms are basically differentiated into two types. The first one is non-preemptive algorithms and the second one is preemptive algorithms. Non-preemptive algorithms are the ones where whenever a process starts its execution, then no other process can preempt it or disturb it. As a result, it will be continuing its execution till it finishes the execution or that particular time is over. Similarly, as far as preemptive algorithms is concerned, whenever a particular process is performing its execution and then if it is priority is lesser as compared to other process, and if a higher process comes and preempted, then this particular executing process will stop, it will go to the ready state and that particular higher priority process will start its execution. This is called as preemptive algorithm. Now let us discuss about the first kind of scheduling algorithm, which is first come first serve or FCFS algorithm. In this case, all the jobs or processes which are coming first are the ones which are implemented first. It is very easy to be implemented and easy to understand also. It can be both preemptive as well as it can be non-preemptive. In this case, since we are using first come first serve, we will be using a first in first out queue. Here the waiting time is very high. As a result, the performance is poor as compared to other scheduling algorithms. Next, let us see about shortest job next or SJN algorithm. It can also be called as shortest job first algorithm. Here we will be considering the execution time of each process, and the process which is having minimum execution time is the one which is considered first. It can be both preemptive as well as non-preemptive. It is best used in case of batch systems where the execution time of each process is known. But in case of interactive systems where we don't know the exact execution time of each process, it is quite difficult to be implemented. Next, we will be seeing about the priority algorithm. Here we will be considering the priority of each process and accordingly they will be scheduled. So how the priority can be considered? It can be considered based on their time required for the memory, time required for execution and various resources which are required by that particular process. So as and when we get a process which is having an higher priority, it will be given first as compared to the process which are having low priority. So when we are getting a process which is having same priority, in such cases it will be considered in a first come first serve manner. Next, let us discuss about shortest remaining time algorithm. Shortest remaining time algorithm is a primitive version of shortest job next algorithm. In this case, the CPU is assigned a job which is closest for completion, but it can also be preempted by another job which is having even shorter time for completion. It is best suited for processes which are in the batch system. This is because we know the time required for each process for execution in advance. But in case of interactive system, it is not suitable because we do not know how much amount of time we require for each process in advance. Next, we will be discussing about round-robin algorithm. In case of round-robin algorithm, it is a primitive algorithm. Here, fixed amount of time will be given for each process for execution. This is called as a quantum. Whenever the process is executed in that particular amount of time, then it will be preempted and another process will continue its execution. Here, context switching will be used in order to save the states of the processes which are preempted. Now lastly, let us discuss about multi-level queue scheduling algorithm. Multi-level queue scheduling algorithm does not have an algorithm in itself. It will be using the existing algorithms in order to group and create jobs based on their common characteristics. Here, multiple queues can be created based on the common characteristics of each job, and then algorithms are assigned for each queue accordingly. Here, priorities can also be assigned for each queues and accordingly scheduling is taking place. Let us come to the end of the session. Hope you all understood about scheduling algorithms in detail. In the coming session, we will be discussing about IO management and disk scheduling. Thank you.